Okay, so formal good afternoon to all the members who have joined us. We welcome you back to attend today's second session of short-term training program. Our honorable expert resource person to address this session is Dr. Harit Shah, sir. Dr. Harit Shah is professor in Department of Biotechnology of Guru घासीदास Vishwavidyalaya, Bilaspur. He has completed PhD in biochemistry from RTM Nagpur University. He has qualified SET lecturership from Maharashtra in February 2002 and CSIR UGC NET lecturership in June 2002. He has published more than 30 papers in national and international journals. I think there is some background noise. Just a moment. Okay. Sorry for the interruption once again. So, Dr. Harit Jha sir is professor in Department of Biotechnology of Guru घासीदास Vishwavidyalaya, Bilaspur. He has completed PhD in biochemistry from RTM Nagpur University. He has qualified SET lecturership from Maharashtra in 2002 and February 2002 and CSIR UGC NET lecturership in June 2002. He has published more than 30 papers in national and international journals. He has also jointly authored two books. They are named as Antioxidants, Source, Activity and Applications, and Lignocellulosis based Composites and Biopolymers. Several projects that have been sanctioned and completed under his leadership include CCOST funded project worth rupees 5 lakhs on lignocellulose polylactic acid based composites for multifaceted applications. A 3-year project on application of acacia and rice husk lignin in the synthesis of biopolymers, biofilms and resins, which was worth rupees 11 lakh 26,000. He was also a group leader in the 5 years project on microbial technology under DBT Builder scheme to boost interdisciplinary education and research in School of Life Sciences, Biotechnology, Botany, Zoology, DBT. This project was worth rupees 3 crore 69 lakhs 80,000. He has successfully completed a 3-year UGC funded project worth rupees 10 lakhs 4,000 on process optimization of conditions for extraction and purification of lignin from agro and forest wastes using physiochemical and biological approaches. Furthermore, he was deputy coordinator in a UGC SAP 2 DRS 1 worth rupees 87 lakhs 50,000 for Department of Biotechnology of Guru घासीदास Vishwavidyalaya. Dr. Jha is also PhD guided. As on date, 3 PhDs have been awarded under his guidance. His expertise has earned him to be a reviewer for international journals like Material Science and Engineering, International Journal of Biological Micromolecules, Chemosphere, Romanian Journal of Biotechnology, Pharmaceutical Biology, Journal of Nanoparticle Research, Bioresources, etc. Dr. Harit Jha, sir, it is an honor for us to have you today as our expert resource person. I will now request you to please start the session. Over to you, Dr. Harit Jha, sir.
Thank you. Uh, Thank you for such a kind introduction. My voice is audible?
Yes, sir, loud and clear.
Okay, okay. If you need to have any, if there are any queries, I'll suggest you can either send it in chat box or at the end of the session you can ask question. Okay, it will help me to like keep a flow of the presentation. Okay. Presentation is visible.
Yes, sir, it is.
Okay. So I'll be speaking on biotechnological intervention for novel products from agroforestry resources. Now, when we talk of agroforestry resources, they are renewable resources. That is why we show a lot of interest in them. Now, what are these resources of biomasses and why we are interested in it? Now, these agroforestry resources include the forestry crops and residues, agricultural crops and residues like rice, husk, cotton, stalk, or wheat, husk, etc. Then the sewage waste, which contains a lot of carbon compounds, and industrial residues, byproducts, which contain a lot of carbon containing compounds, and unutilized organics, then animal residues of fecal materials, then municipal solid waste. So these resources are the major resources of biomass. Out of this, what I am interested in is in agroforestry waste, especially the crop residues which are coming from the agricultural operations, like rice straw, wheat straw, husk, stem, barley straw, grass seed straw, flax coil seeds, sugarcane bagasse, on which I also had my PhD. So, cotton staples, stem fibers, etc. These waste are important source of carbon, although they are agro waste and they are not utilized for major economical work and have very low economical value, and thus it remains improperly utilized. They are utilized but improperly utilized. So a strategy is required to convert these product of waste into value-added product. Now, the important thing is that although these agro waste is easily available, they need to be converted into something which is economically viable, something which will give high value to this particular components which are treated as waste. So the process of this conversion should be efficient, economical, with relatively ease of operation, so that the common farmer should be able to optimally utilize its resources to generate secondary source of income. Now, this is a major issue. Like our economy also has the agriculture is a major source of income for most of the people, and a large proportion of people are also involved in the agrarian operation. So, but the income which comes from the agricultural operation are dwindling. It is decreasing day by day, due to which the people who earlier when 75% of our GDP was from agriculture, now it has dropped down to around 20-25. The per capita income coming out from the agriculture has also dropped. So the fertility is decreasing, even though the yield is increasing. Still, the amount of money which could be generated from the agriculture operation is not so much so to support the farmers properly, especially the farmers with smaller land holdings. So they need a secondary source of income besides the agricultural operation. So that can be done if we can convert this agro waste or byproducts of the agricultural operation into some value added component. Right now, what we are doing with this agro waste, normally these are used as a fodder, as a fuel for domestic fuel as well as industrial fuel, as well as some of these components are used in the timber industry. So the amount of money that can be generated, the amount of value that is imparted to this particular agro waste is very low. Okay. So, for example, I was working on sugarcane bagasse. I needed it to, when I went to some industries, sugar industries, or uh, to places where sugar juices were extracted, where when I asked for the sugarcane bagasse, they gave it to me freely without charging anything. Obviously, why they did though? So because obviously they felt that that particular material is not useful for them. So they, whoever takes that, that's good for them. So they wanted to dispose of these agro. So even today also the stock uh, burning is a major issue out in the North India. So we need to find out the use of this agro waste properly, efficiently, and so that we can generate large amount of money from these agro waste also. Now, what is the basic composition of agro waste? Obviously, they are plant products, so they contain cellulose around 33%, and that can vary up depending upon the plant species, and hemicellulose, lignin, and some other compounds. So these compounds are arranged in such a manner that about which we'll be discussing later. Cellulose is arranged in form of fibers, say linear fibers, which is line fibers, and bound to it is normally the hemicellulose, and around them, binding this cellulose bundle and hemicellulose, which are acting as matrix between cellulose fibers and cellulose bundle, is the lignin. Okay, so this is the general composition of the agro waste, especially the wood. The cellulose and lignin are are the most abundant materials on the organic material on the earth. Cellulose being the highest in highest concentration, followed only by the lignin. And they can be, if properly used, can be utilized for the production of value-added products such as biodegradable film, foam, resins, coating, drug delivery, nanocomposites, nanomaterial, etc. So most of the components, whether it is a drug or whether it is a polymer, that foam, resin, coating, etc. Many of these things are made up of the carbon. Now, if we have the capability to convert this carbon compound into something useful, and it's a major renewable source of carbon compound, can be converted into useful components, then it will be beneficial for all of us. Right now, we are not using them properly, but if we can use them properly and convert them into components which have high value addition, they can be quite beneficial for the whole system. Okay, so the farmers will not only get rid of this waste, farmers and the uh, forest officials, but they will also be getting a secondary source of income with these waste. So these lignocelluloses thus refers to plant biomass that is composed of cellulose, hemicellulose, and lignin. And this carbohydrate polymers like cellulose and hemicellulose are tightly bound to the lignin. And these lignocelluloses biomass can be grouped into four main categories, that is agricultural residues, including corn, store, sugarcane, bagasse, etc., dedicated energy crops from which we normally get energy or which are used as a fuel. For example, jatofa and current, which are used as a biofuel in many cases, green fuel. And the babool, which is a source of the fuel, and wood residues, including the sawmill and paper mill discards and municipal waste paper. They all are the lignocellulosic biomass. And just to give a glimpse of the cellulose structure, as you can see, cellulose is a part of the plant cell wall, and it forms a layered layer. Okay, so microfibril like structure is present. So this is the cellulose, crystalline cellulose forms layers. It is made up of glucose and cellobiose. These glucose and repeating glucose units form a crystalline and paracrystalline cellulose layer. This crystalline and paracrystalline cellulose layer are then covered by the and bound by the hemicelluloses, and the hemicelluloses are bound by lignin. So this is part of the plant secondary cell wall. And cellulose, this is a organic compound with a formula C6H10O5, and it's a polysaccharide consisting of a linear chain of several hundred to thousands glucose unit. And we can get this cellulose in paper mill through a craft process or other pulping process. And cellulose is removed from the lignin and is used for the paper, paperboard, cardstock, textile, and What are hemicelluloses? Hemicelluloses is are group of heteropolymer matrix polysaccharides such as arabino or valine. And while the cellulose is crystalline and white and resistant to hydrolysis, the hemicelluloses are random amorphous structure with little strength. It is relatively easily hydrolyzed by dilute acid or bases. Some of the example of hemicellulose include xylene, glucono, uh, xylene, arabinoxylene, gluconomalin, xyloglucan, etc. Okay. So they can they are normally consist of monomers, the homomonomers or heteromonomers also. And mostly they contain D pentose sugar and occasionally a small amount of L sugar. Okay. Now, this is a general outline about which we have discussed. Although I have worked on cellulose and hemicellulose, but the uh, compound of interest was lignin. My earlier work during my PhD was on degradation of lignin, but later I found that only degradation is not required. The lignin as a whole can be also quite used. So the lignin is a three-dimensional network buildup of the dimethoxylated and non-methoxylated phenylpropanoidine like syringil, voicil, and parahydroxyphenyl unit. And they are derived from the parahydroxycinnamyl alcohol, and they combine together through a free radical mediated process. Peroxidase enzymes are involved. So these monomers then combine together to the coniferyl alcohol, comeryl alcohol, and sanapiryl alcohol, etc. They combine together to form the large polymeric lignin. Now, the important thing to remember that lignin of one plant may differ from lignin of another. The reason being that the kind of cellulose and hemicellulose structure which is present, their arrangement, as well as the free radical mediated interaction is sometimes random. It is not focused and a very specific interaction. So this random interaction between the charged coniferyl, comeryl, and sanapiryl alcohol or voicyl alcohol, that may lead to different type of lignin. So the lignin structure of say rice straw will differ from slightly differ from wheat straw or from the acacia, etc. So plant to plant there will be variation in the type of lignin which is present, and that variation can also be utilized for getting different type of compounds from it and different applications. General, as we many applications of lignin include the biopolymer formation. It itself is a biopolymer. So, and it has because it is a polyphenolic compound. It has got antioxidant activity also, and as it provides a defensive mechanism to the plant system. It protects it from the microbial pathogenic attack. So it is also having a antimicrobial activity. Uh, it can also act as plant growth promoter, as a metal ion chelating agent because of its charged structure, as a surfactant because it can change the surface tension of many solutions. It can be useful for synthesis of nanofibers, carbon fibers, and carbon nanotubes. Then for preparation of aerogels and hydrogels. Aerogels means some a gel-like material which has got extremely uh, low density. So that is why the name aerogel. Then they can be the lignin can be utilized for synthesis of different type of composite material. Now, the lignin can be further biotransformed because of its large polymeric structure. It can act as a major source of different type of aromatic and aliphatic compound, mainly aromatic compound. For example, the vanillin, dimethyl sulfide, dimethyl sulfoxide, phenols, glycols, and acetic acid, phenol, catechol, acetylene, and ferulic acid, comeric acid. So these large type of compounds can be obtained from a single lignin molecule by using different type of reaction, including pyrolysis, fast thermolysis, alkali fusion, enzymatic oxidation, microbial conversion, hydrolysis, hydrogenation, and oxidation. So we can use any of these reactions to obtain different type of compound. The only thing is that you need to standardize the structure of the compound. Now, fractionation process of the lignin and cellulose can provide us different kind of components. For example, through an integrated fractionation process, we can break the agro waste into lignin-rich fraction and cellulose-rich fraction. The lignin-rich fraction, this is an example of one of the process. The lignin-rich fraction can be further attacked by the lactase enzyme or peroxidase enzyme or the manganese peroxidase enzyme, which are the enzymes which are involved in the lignin degradation process. And by using these processes, we can achieve the lignin degradation products, which can be used as the value-added chemicals, as we have seen in the earlier slide. Similarly, if we remove the lignin, the cellulose, the remaining cellulose can be treated with the cellulases and we can get the glucose. So this whole process is called the saccharification process, in which we get the sugar or sugar-based building blocks. Okay, these saccharified solutions can be used for fermentation product as a source of the carbon for various different fermentation processes. Okay, I think you all had a presentation or lecture on the biofuel production also. So the lignin can also be used for biofuel production. So in which if we have the recombinant plant system or genetically engineered plant also, that can be also used. So non-transgenic or transgenic plant can be pre-treated for breakdown of the cellulose and then the further enzymatic and digestion and fermentation process can produce the bioethanol or biobutanol. And these bioethanol and biobutanol can be obtained through the fractional distillation processes. We can also further directly degrade it with the help of the lignin degradation product, which can also act as the fuel additives. The lignin degradation product can have high calorific value and thus can help act as a fuel additives also, uh, providing the increasing the efficiency of the fuel and increasing its average of that particular fuel. In this process, normally we take the raw mass, biomass, and undergo hydrolysis, fermentation, distillation, dehydration. And this dehydrated fuel is then used for adopted and used for distribution, and then further for heat and power production. Okay. So this is a schematic the diagram of the fuel or different type of products which can be obtained from the lignocellulose waste. So, for example, you are must be aware of in Ballarpur you have a paper mill also, and besides that, in a small paper mill, the kraft pulping process takes place, and the byproduct of that kraft pulping process is black liquor, and from that we can process and obtain the kraft lignin. It is partially modified alkali lignin, and this can be used for breakdown and oxidation us to produce many of the phenolic compounds. The pulp can be then used for the paper production. Lignin can also be used for production of biopolymers and biofuels. And through various membrane processes, we can further purify the compounds which we want. For aromatic products also, we can use the ionic fluids for breakdown, and using catalyst, we can break the lignin. These are some of the products which can be obtained using the lignin, like carbon fibers. Uh, Carbon fibers are what? What are carbon fibers? They are obtained at extremely high pressure. The carbon compounds is high pressure and temperature. These carbon fibers are produced, and they have strength, extremely high strength property. So the disposable products can also be produced using the lignin and lignin-based components. Household products can be produced. Carbon black can be produced using the components. Hydrogel and aerogels, which are extremely light weight material but with good strength properties, can be used. As a concrete additive, we can use the lignin. Uh, when you use it as a concrete additive, it reduces the fractures in the concrete. So, because it has a high calcium binding potential, it binds with the cement material and does not allow it to fracture during the stress condition. They can be used for as emulsifying agent and emulsion itself. They have been used as road dust controller. The solution of the lignin, the modified lignin, is sprayed on the road so that it binds with the dust particle and do not allow them to spread out. Okay, so this is how the road dust controller acts. Then many this lignin carbon fiber based systems are also used for production of the car and other things. Their panels, they provide the high strength properties also. Now, these are some of the companies which are and organizations which are involved in the lignin and its modification and lignin based products. So, the whole companies have been formed for the utilization of the lignin and selling their products. Now, what this is all which is available in the public domain. How what is lignin, what is the agro waste, how the lignin cellulose and the hemi celluloses are being used, how the lignin can be converted into one form of product or another form of product. But what we have actually done, this is what I'll be discussing in the next part of the presentation, and how the work has been carried out, whether this is viable or not. I'm talking about lignin, that lignin can be used in this and that. But whether it is actually productive, whether it can be actually converted into biopolymers, whether it can be actually used as biopolymers, whether it can be actually used as a drug component. So, what are the actual possibility of lignin and using the lignin-based component? So, as you must have heard that our first project, initially my PhD work was on lignin degradation. Then my first project was on the extraction of the lignin from various agro residues, because depending upon the extraction process, the lignin quality changes, the types of bonds which are present, the types of polymeric structure which is present will change. And when the lignin structure will change after extraction process, obviously its property also changes. So our first project was on the optimization of conditions and to determine which particular extraction process can be useful and which we can have a different type of lignin and which lignin can be useful for our application. So how you extract lignin, from where you extract lignin, will decide the type of lignin which you are getting, the quality of that particular lignin, and what kind of products can be obtained from that particular lignin. Okay. So this is how we started alkali lignin, hot water lignin, solvent extracted lignin. Then I have not mentioned two, three other methods, including the ethanol extracted lignin, the enzyme modified and enzyme extracted lignin. So many different type of lignins were extracted from. We have focused on acacia and rice husk and straw. The reason being that these two plants are quite common in central India, especially Chhattisgarh. So we have focused on these one agriculture waste, that is the rice straw and husk, and one forest waste, that is the babul based wood dust. From that we have extracted the lignin and compared their property. And based on their property, we have also checked their antioxidant potential, anti-cancer and cytotoxic potential, as well as the antibacterial potential. And based on that, we have, I'll show you that we have published some work also. So we found that depending upon the kind of extraction, the alkali extraction gives you highest possible yield. If you want a lignin which is relatively non-modified, least unoxidized, in that case, you need to go for the enzyme extracted lignin process. So the enzyme-based lignin extraction process or will give you the lignin which is least modified. Okay. So these are the products which we have actually made. Okay. Like resin material and the biomaterial, the composites which we have made, the biodegradable films which we have made, and foam-like material, which is a biofoam. Besides the various different kind of therapeutic applications which we have uh, tried to analyze. This is one example of lignin alginate polymer which we have made. Why we went for lignin alginate polymer? The reason being that alginate is a carbohydrate, lignin is a polyphenol. Lignin has the tendency to actually bind with the carbohydrate under certain optimal conditions. So in plant cell wall system in situ condition also it forms bind and binds with the carbohydrate system, the hemicellulose and celluloses. So in vitro condition also, if we use the lignin along with the carbohydrate with the help of suitable catalyst, they will form a complex. And these complex have a filmogenic property or polymeric property also. And that is why we use the lignin and alginate. We have also used other kind of carbohydrates also for like lignin starch complex, which was used for many different applications. So after using the different type of plasticizer for binding and cross-linking of the lignin, we have compared their physico-mechanical properties, including the thickness, moisture content, water solubility, swelling properties, bursting index, the tensile strength, etc. So that the strength properties of these components, as well as their other properties, can be measured, and we can find out which particular component or which particular system is good enough. Then we also blended the lignin with gelatin. Lignin and tannins have the uh, property to precipitate the protein. They not only sometimes change the pH of the system, they can also interact with the uh, gelatin and other proteins. And this interaction was utilized for making lignin gelatin based uh, film. So again, we have measured the thickness property, moisture content, water solubility property, the swelling property, bursting index, and tensile strength. Different types of lignin gelatin combination and under different conditions we prepare so as to achieve a film with highest of desirable parameter. We also did some AFM topographic analysis of this particular lignin to see the smoothness and the for 3D visualization. We also tested the DPPH and the antioxidant and cytotoxic activity of these lignins. We intended to use it as the wound healing component, and we also wanted to know whether if we are using it in the wound healing system, what could be the possible effect of the microorganism as well as the cells. Then one of the important uses or application of this lignin alginate or lignin gelatin or lignin based film is that they can lignin being a polyphenolic compound, it can absorb a large amount of ultraviolet ray. And if you use these film as food packaging material, and in food packaging, one issue that occurs is that the light rays may tend to uh, destroy or disrupt the food material. So they adversely affect the quality of food material if food material is packaged in a polymer. So if lignin is present, it tends to absorb a large amount of the ultraviolet ray and thus protect the food product from any deterioration. So the shelf life of the food material can be increased if you incorporate lignin into these components into the film. And these films are biodegradable or in nature also. So they are not bioaccumulating in nature. And the alginate, especially alginate and part as well as the lignin alginate bonds are broken down easily by the soil microflora. And after degradation, the lignin can again get into the carbon cycle along with the degradation products. And if we want, we can also create a system, a in vitro system or a in vitro bioprocess, or which can be developed for degradation of these lignin gelatin film or lignin alginate films in an institutional manner. Okay, so you can collect these products from all the consumers and then degrade them in a system. These polymers have also been used by us for drug release study. We have tried to test them and see whether they can be used for slow release of the drug, and we have been successful also. Depending upon the pH, we have taken the fluconazole as a standard drug, and by varying the pH uh, and time, we saw how much time it is taken for release of a particular compound. If you use a for LA polymer, that is lignogenate biopolymer, for release of the compound. Why we want to do that is that many of the drugs require a constant high concentration in the blood system. But when you directly ingest these tablets, they are absorbed and then metabolized to be released from through the excretory system. So the time spent in the body system or the what you call their half life is not much. But if we have a slow release system, it slowly releases the drug into the body system, and it can be quite useful because it will maintain the concentration of the drug within the circulatory system for a longer duration. That was the purpose for which, and lignin and alginate are relatively non-toxic, so the body can easily sustain this. So sustainable systems can be created using the lignin. We have also made lignin-based resins and adhesives. Okay, about which we have also made nanocomposites and nanoparticles using lignin-based systems. Okay, so I'll first discuss this nanoparticle and nanocomposite. These nanoparticles and nanocomposites were used along with the silicate system because silica is also present within the, especially the rice straw system. So when it is present naturally in the rice straw system and the wheat straw system, if we isolate them separately and then use them to combine in vitro condition, in lab condition, what will happen? So this is what we have done. So for we have used lignin and TUS for and modified lignin, especially along with the TUS for synthesis of the lignin TUS hybrid or lignin TUS composite mixture. So this composite mixture was then analyzed using the scanning electron microscope. The structure was analyzed. We also found that there are a lot of pores which are present in structure, uh, and they also were charged. So we use this particular combination, that is lignin TUS complex, for separation of the unbinding of the metal. So many of the water samples and especially the industrial effluent contain nickel and cadmium and other toxicity. Those high concentration of metals can be removed based system. So this silicate composite based system can be used for designing of the column and or the beads which can bind with the uh, specifically and then can remove them from the system. So for removal of these metals specifically, we can use this lignin silicate uh, system. So as you can see, the this is a structure of humic acid and fulvic acid. This is the model structure of humic acid and fulvic acid. They are phenolic in nature, aromatic in nature, and are similar to the lignin. So this is the uh, basis of idea that if the humic acid and fulvic acid, which are formed from crop residue, they share a part of their structure with the lignin. So, and their humic acid and fulvic acid are growth promoting in nature. So, why not lignin? So, this was the basis of or the hypothesis which we have used for using the lignin as a growth promoting. So, we tested the growth of uh, plants in presence and absence of the lignin TUS and the in presence of lignin TUS complex. We also did some study to understand the biochemical changes which are taking place within the plant, as well as the morphological and physiological changes which are taking place inside the plant system. We found that overall the growth was promoted at low concentration of LTC, that is lignin TUS complex, at low concentration. At high concentration, it was quite relatively toxic. At low concentration, it promoted the plant growth. How it did that? We found that it activated the formation of root hair. So the root hair formation was activated or promoted due to the presence of lignin and the TUS complex. This led us to also propagate the hypothesis that the lignin TUS complex or lignin alone can also be useful in promoting the root growth and thus overall growth of the plant. Okay, this is the other structural properties of the lignin TUS complex, which we have seen. Their FTIR, that is infrared spectrum, was studied in alone and in combination. That is, as well as we have also studied the uh, we also studied UV visible spectrum of the TUS and also the thermal properties, that is the stability of that particular compound uh, and the particle size distribution of the lignin sulfonate as well as the lignin TUS biocomposite. The paper was published in a very good work was published in a good journal, that is Biotechnology Reports, we have used the rice husk extracted lignin to use composite. And we have also made certain modification in the structure, including the acetylation and silane surface treatment, so that the nickel removal can be improved. The acetylation and silane treatment change the uh, hydrophobicity and hydrophilicity of the complex. Okay, these are some other studies of the lignin alginate and lignin gelatin complexes, which we have used as a food packaging material, about which we have already discussed. That we have incorporated lignin in the gelatin, and this lignin gelatin complex had lower glass transition that temperature and have as compared to the uh, gelatin, they also have better stability and high interaction. And uh, and this interaction was due to the hydrogen bonding and hydrophobic interaction. We had also done the AFM of this and shown that the light barrier properties was also good. So this was again published. This work was published in the Bioresources Bioprocessing. Okay. And the resin about which we have discussed, this lignin-based resin was also uh, prepared in presence of phenol and formaldehyde. And this lignin-based resin was extremely sticky and had a high strength properties and high thermal stability also, which we have discussed. Now, this resin was also used along with the other analysis. I have used it for sticking of the and binding of the wood boards as well as tiles. So the tiles and wood boards will all stick together. Wherever we found this loose hanging tiles or loose hanging boards or sun mines, there I have used the lab produced lignin based resin also. So this is quite useful and it can be easily prepared in at high at 80 degree or so temperature. Under these conditions, you can prepare the resin. Okay, these are the structure and DSC gives us the differential scanning calorimetry. Gives details about the stability of the particular complex. That also we have seen. Okay, this is the thermal degradation profile. What temperature the lignin is, and based resin will be degraded. Okay, and we have compared with the control. So the properties are comparable with the control resin. Okay. Then we have used the carboxy methylated lignin and the US complexes. Uh, and these complexes were used for antimicrobial activity. So we found that they have got a positive antimicrobial activity. These are the FTI spectra where we have seen the interaction between the lignin and TU. Okay. This is again the structure of lignin and TUS. This is lignin uh, uh, at 1 gram of TUS with 2 gram of TUS and 3 gram of TUS. So we have a different structure with the increasing concentration of TUS. TUS is a silane. This is a X-ray diffraction spectra of all these three different combinations: lignin, carboxymethylated lignin, and the TUS compound. Then we have seen the absorption of nickel at different concentration of composite and nickel as well as the cadmium at different concentration, different type of lignin and CMLT complex. And these are the different parameters under which different conditions, that is the condition of pH and time, in which we have measured and analyzed the removal of the lignin. This was the paper which we have already and how this is how the removal of the lignin took place. That That is, the complex was there. Removal of the nickel and cadmium took place. That the complex or composite was used. The metal solution was passed to that particular column, in which the lignin silicate complex or composite was added and attached. So through this column, the metal solution was passed. The effluent was then tested using the atomic absorption spectroscopy for the presence or absence of the metal ion and the concentration of the metal ion. And based on that, we found that this lignin TOS complex, which was formed through the soul gel mechanism, this showed high interaction with the nickel and cadmium and was able to remove high concentration of nickel and cadmium. Okay, this is again the whole uh, process. Okay, now this heavy metal dust can be removed using this particular process. Okay, so this we have shown that we can produce resin, we can produce the biopolymer using using lignin as one of the component, and adding carbohydrate or and silica, that is an inorganic component, to improve the property of the lignin. Lignin in itself is a amorphous compound, but when you combine it with different components, it can create a variation in the property of the lignin. And in itself, lignin is antimicrobial in nature and can also kill. It can be also cytotoxic, especially for the cancer cell, if you make certain modification in it. So, in the one of the latest paper, 2019, we have synthesized silver nanoparticle using cassia lignin. They were then further stabilized. The silver nanoparticle have the uh, tendency to agglomerate. That is, they convert back into the silver complex, and they also agglomerate. That is, they form a uh, aggregation of those particles. So its nano property is lost once it performs the agglomerate or from a collection of those particles. So normally we also use lignin for stabilization of this particular silver nanoparticle during the whole process. So synthesis as well as stabilization is through lignin. So we have synthesized this silver nanoparticle, and then we further tested cytotoxicity and catalytical property and metal sensing capacity and the antibacterial activity. So we found that the acacia lignin and along with the silver nanoparticle, that is the silver nanoparticle, stabilized with the acacia lignin, has the ability to sense the metal. It has ability to kill cancerous cell, and we have used 7 different cell lines, cancer cell line, for testing the anti-cancer activity. Then further, its catalytic activity was also tested, and antibacterial activity against certain selected uh, microbes which are pathogenic, especially bacteria. So they were pathogenic. These pathogenic bacteria was killed by the silver nanoparticle. Obviously, the silver nanoparticle have high toxicity. The only problem is their stability. So, along with lignin, which itself is antibacterial, so the activity was synergistic in it. The lignin and silver nanoparticle were able to do a high antibacterial, good antibacterial activity comparable to the standard control compound. Then we also use the nanofibers and synthesize nanofibers using the silver nanoparticle loaded polyvinyl alcohol lignin electrospun nanofibers were prepared, and then antibacterial activity was uh, uh, tested. So in that, what we had done is that we have prepared and used the polyvinyl alcohol and combine it with the lignin. and there is the electrospun, that is for the nanofiber synthesis. So electrospinning is a process through which the dark material can be spin at high uh, pressure under a specific electric field. And from that, the nanofibers and nano material can be synthesized. So this is the kind of nano films and fibers which we have prepared using electrospun technique. We took it electron micrograph, and as you can see that the network of fibers are present using the lignin. This fibers will uh, then further visualized, and we also found that they are loaded with the lignin as well as the silver nanoparticles. Silver nanoparticles scattered throughout the lignin base nanofibers, and it showed a high amount of antimicrobial activity also. So these films can be then used for wound healing purposes. आप इससे लिग्निन पीवीए के बड़े लेयर्स बना सकते हैं, फिल्म्स बना सकते हैं और उसको वुंड हीलिंग के लिए यूज कर सकते हैं, क्योंकि इसमें पहले ही एंटीबैक्टीरियल माइक्रोबियल एक्टिविटी है and it does not allow the water to pass through easily. So it will be an ideal wound healing material. Which we already seen. This is the initial work we had started, that is free radical scavenging activity and reducing power of cassia nilotical wood lignin. Initial work about which I had discussed that using the Babula acacia nilotica we had extracted the lignin, and this lignin was tested for the free radical scavenging activity. We have also partially modified the lignin and then test using the lignin degradation enzyme or ligninolytic enzyme. And then we have tested their in vitro antioxidant and anti-diabetic activity. And this was also published in a good journal, that is International Journal of Biological Macromolecules. We have also used the lignin for hydrogen peroxide sensing and cytotoxic activity. For the sensing of the hydrogen peroxide, that is the presence and absence of the hydrogen peroxide can be detected using this acacia lignin stabilized silver nanoparticle, because the color will change depending upon the presence of a very small concentration of the hydrogen peroxide also. That we have used. Then we also tested the cytotoxicity of this acacia lignin stabilized silver nanoparticle on cancer cell lines. This is a synergistic antibacterial and antibiofilm activity of silver nanoparticle biosynthesized by lignin degrading fungus. So here what we have done is that we have used the lignin degrading fungus, which we have used for biotransformation or biomodification, and use this fungus in their enzymatic system for modification of silver nanoparticle. And that was used for antibacterial and antibiofilm forming activity. Then we have also, this again was our initial work in which we have tested the in vitro antioxidant and cytotoxic activity of lignin, which were extracted from the acacia nilotica. Okay, तो acacia nilotica से जो हमको lignin मिला था उसकी एक्टिविटी भी हमने टेस्ट की थी और antioxidant and cytotoxic activity. This is again our latest paper on synthesis and characterization of lignin polylactic acid film as active food packaging material. Uh, so in this, what we have done is that polylactic acid, which is a byproduct of most of the bacterial system, uh, like we have a lactobacillus bacteria, it also produces lactic acid. So that sour taste or sour smell by the bacteria is due to the production of lactic acid. This lactic acid can be converted into polylactic acid by a uh, stannous or tin-based catalytic reaction. So in that we have also used lignin, and this lignin and impregnated polylactic acid was then used for uh, was synthesized and characterized, and by using the scanning electron microscope, X-ray diffraction, differential scanning, calorimetry, TGA analysis, etc. And after its analysis, we tested its strength property and physicochemical properties also, and, and surface properties. Uh, we found that this lignin was thermostable and amorphous in nature. And further, there was a significant improvement in the antimicrobial activity and biodegradability of this PLA film after the addition of lignin. So we also tested it for packaging application, food packaging material application, and found that it does not causes any toxicity, and it does not cause any chelation, and can be degraded under suitable condition. So this was what we have done using the polylactic acid as a and lignin. So this is what I was discussing, that we started with lignin. Okay, and in whole of the system, we have used this lignin for synthesis of polymer, for synthesis of resin, for synthesis of adhesive, for drug release study, for as an antioxidant, for wound healing material, etc. So one component has so many applications, and some of these applications can be done at small scale at the farmers level also, once the process is properly optimized. In that case, at a small scale also, the farmers can bioconvert or convert the lignin based substances or agro waste into useful products and can sell them. And then lignin based economy, a parallel economy, can be generated along with the initial product. Okay. So this is what I intended to discuss, that agro waste can be converted into value added products. Like we could convert them into so many products. So there are already a lot of studies which are available, which shows that lignin and the agro waste can be converted into uh, n number of products. And these products, uh, in one more study, for example, this study, what we have done is that we have biodegraded one of the dye using the fungus we found for biotransformation, and we also propagated a whole pathway with the degradation take. So this is the offshoot of the work which we were doing. So this is what I tend to uh, uh, I wish to say, that if even if you use one component from the whole agro waste, you can turn out many hundreds of different type of products, and that too under the conditions which are not very extreme condition, the conditions which are relatively easier to manipulate and control. So if we can do that, uh, it will be quite useful, and uh, and can help the farmer and the farming industry also. Thank you. Now, if you got any questions, I'll be happy to take them.
Yeah. So all the attendees are requested, in case if you have any queries or any doubts, you can, or if you wish to share your experience as well, you can just unmute yourself and talk to our expert speaker directly. In case if you are not comfortable in unmuting yourself, you can type in your queries in the chat box
That,
and
that,
we can read them out.
You can also take note down those papers, research papers, which I also share the title. All the details and methodologies, etc., are available if you are interested. Yeah, most of them are in public domain, free access.
Sir, we will wait for a minute and see. Generally, it takes time if they are sharing the questions in chat box. Then generally it takes them some time to share.
Okay, I'll wait. The lignin is also available as a lignin sulfonate, uh, which is and pure lignin, which is provided by Sigma as well as high medium. If somebody is interested in using those, that can be done.
Okay, so I suppose that there are no questions or queries. So thank you very much, sir, on behalf of Ballarpur Institute of Technology and on behalf of the organizing committee of this short-term training program. I would like to thank you for such an in-depth session.
Thank you, thank you, thank you for inviting me.
Okay, and now
Uh,
to all, yes, sir.
uh, Now, shall I leave the presentation? Okay.
Yes, sir, that is like it is up to you if
If
you.
there are any other queries, you can always pass it on to me. I'll be happy to answer those. Okay.
Sure thing, sir. Yes, sir. So all the attendees are requested to please stay tuned with us. We will be sharing a short presentation now, wherein the basic instructions about the faculty develop about the short-term training program are covered, and we would like to inform you about the timings, about the topics which we will be covering, and we also have best participant award for all those who will be participating regularly and who will be interactive during the sessions. So please stay tuned. I hope that my screen is visible. If somebody will please confirm if I am audible and the screen is visible.
Yes, sir.
Okay, thank you, ma'am. So let's continue. We have discussed this once before at the start of the session. We would like to discuss it once more. There are few more points which are to be discussed, which were not discussed at the beginning of the session. So please stay connected with us. Like all of us are aware, it is a 1 week short-term training program on biotechnology and its application in tribal agriculture areas, which will be conducted from November 23 to November 28th, 2020, all in everything in online mode, and it is sponsored by All India Council for Technical Education. The timings for the day first, that is today's timings were 11:30 a.m. to 1:30 p.m. Then from 1:30 to 2:30 we had a break, and from 2:30 to 4:30 we had another session. However, this is very important. Please make a note of this. I request to all the attendees to please make a note of this. From tomorrow onwards, the timings will be for the first session. The session will start at 12:30 p.m. and it will go on till 2:30 p.m. From 2:30 p.m. to 3:30 p.m. we will have a break, and from 3:30 p.m. to 5:30 p.m. again we will have another session. Okay. So because today was the first day and we had our inaugural function, so we had to adjust the timing as per the availability of our chief guest, Honorable Dr. G. Balasubramani sir. However, otherwise the STTP timings will be this. Okay. Now, some basic information. This entire STTP will be conducted on Google Meet. Okay. The link to join STTP will be shared 1 hour before the start of this training program. Like usually, because the training program starts at 12:30 p.m., so you will get the link by 11:30 a.m. Then the link will also be valid for one entire day of STTP. Today there were many queries. Some candidates were asking as to whether for the second session there will be another link. So once a link is shared, that link is valid for both the sessions, for the first session also and for the second session also. You can join using the very same link. And now the shared link will be valid for like it is said, the link will be shared only on WhatsApp group, which is named as AICT STTP at BIT. We had in the morning also urged, and again now we would like to request all of you, in case if anybody has not joined this WhatsApp group, please let us know, because the link to join the session will be shared on this WhatsApp group. The feedback form links will also be shared on this WhatsApp group. At the same time, all the tests, for which you have to appear and all, they will also be the link to solve those tests and all will also be shared on this WhatsApp group. So that is the reason. In case if anybody has not joined this WhatsApp group, please do let us know, and we would forward you the link in the group chat of this meeting. Our honorable co-coordinator, Professor Neeraj Bains sir, has already forwarded the link. However, we would forward it once again if it is needed. Now, the time of STTP, as we have already discussed, is from 12:30 p.m. to 5:30 p.m. daily. On some days, an additional hour will be additional hour or one additional hour session will be conducted for revisions and practice test. The final test will be conducted at the end of this STTP, and e-certificates, very important. E-certificates will be issued only to those candidates who will score 60% or more marks in the test. So all in all, to get the e-certificates, you have to satisfy three conditions. The first condition is that of attendance, which is mandatory that you have to maintain. Second is you should be attending sessions on those particular days when it is compulsory, like the inaugural function, the valedictory function. These 2 days it is compulsory. You cannot take a leave on these 2 days. Apart from this, in the exam, you have to score 60% or more marks. So that you are eligible for e-certificate. So all these three conditions should be satisfied. Then the attendance will be monitored and is compulsory to receive the e-certificate. Please make a note of this. Another request is that while entering into the meeting, please make sure that you enter your own name. Today in the morning, this instruction was provided by our co-coordinator, Professor Neeraj Bains sir, that while entering into the meeting, please make sure that you enter with your own name, because we are monitoring attendance only and only through Google Meet apps, and the name that it considers is the name that you enter while joining the meeting. Okay. Now the STTP link is at times shared with the council and monitored by the council, and therefore it is requested that you ensure that your attendance is maintained. The final test will be a MCQ test. By council here we mean our organizing council. Okay. The final test will be a MCQ test, so it is a multiple choice question test. So you need not worry a lot about it. What we do is the questions in the test will only be asked from the revision conducted. So we'll be conducting a revision, and from that revision the questions will be asked. Now, attendance on the inaugural and valedictory are compulsory. This is something that we had mentioned earlier as well. Now, minimum 80% attendance is compulsory. So, of the 6 days, you ensure that 80% attendance is compulsory. Another is biotechnological interventions for the topics which will be covered. These are the topics that will be covered in this STTP. The reason why we are sharing these topics is, in these particular topics, if you want something something in addition which you want to share, then what you can do is you can always let us know after this, because right now we will read out the topics which will be covered, and after that we will ask your suggestions. In case if you want that in this particular topic we would want the speaker to cover this portion or something like that, then we can always request our experts to cover such portions. We cannot guarantee it, of course, because it is up to the experts. However, we can always communicate the requirement, and if that is met, then nothing like it, that would be best for all of us to happen. So the first topic which would be covered is biotechnological interventions for novel products from agroforestry resources, which has been covered by just now. It has been covered by Dr. Jha sir. Then another topic which will be covered tomorrow is introduction to biotechnology and its application in different sector. Dr. G.K. Awari sir, who is head of the department in Government Polytechnic, he will be covering this topic. And there is one more topic another tomorrow which will be covered is synthesis of biofertilizer and biopesticide from agriculture waste using biotechnological tools. This topic will be covered by Dr. Praveen Patil, who happens to be professor in Narsimhanji Institute of Management Sciences, Mumbai. He will be covering this topic. And then another topic is biofuel, the benefits and afflictions. I suppose that this topic will be covered by Dr. Samir Deshmukh sir, who is professor in LIT. There are many more topics which will be covered, and we have written like we have listed them here. I would like to read them out. Biotechnological advancement to minimize post-harvest losses in fruits and vegetables. Advances in biochemical engineering. Role of fermentation in treatment of tribal malnutrition. Then global challenges and direction for agriculture biotechnology, and global challenges and direction for agriculture biotechnology. As you are already aware, our coordinator for this program is Dr. Archana Nimkar ma'am. She is professor in Ballarpur Institute of Technology. Her number is shared here. In case if you have any queries or any doubts, you can always contact her, and you can also contact our co-coordinator for this STTP, Mr. Neeraj Baisar. He is also professor in Ballarpur Institute of Technology. His phone number is also mentioned here. Excuse me. Now we would like to invite your suggestions. In case if there are any suggestions from your end, wherein you would say that, sir, we would want this particular topic to be covered, or in this particular topic we would want this particular portion to be covered. So if there are any suggestions from your end, please let us know. We are open to your suggestions. You can unmute and you can tell us, or you can simply type in the chat box and